Somewhere in Arizona right now, a process engineer is standing on the floor of the most advanced chip factory ever built on American soil. She came here from overseas, trained for a decade in a skill almost no one on Earth has, and she is doing the work the entire country is counting on. And quietly, in the back of her mind, she is carrying a worry that has nothing to do with chips, whether her visa will let her stay in this country long enough to finish what she started. If you are an engineer, a technician, or a scientist who came to America to build at the frontier, this episode is about you. Because the story you are about to hear is not really about machines. It is about the people who make them, the immigration walls they run into, and the pathways that can let the most exceptional of them stay. Stay with us, because by the end, you will understand the breakthrough that changed everything, the immigrant talent it depends on, and the specific green card strategy that researchers in this exact position keep overlooking. Here's how it starts. We are breaking down everything you need to know. Check the timestamps on your screen to jump straight to the segment that impacts you more. Every smartphone in your pocket, every electric vehicle on the road, every AI system running somewhere in the cloud right now, all of it runs on chips. And for the last several decades, almost all of the most advanced chips in the world were made in one place, Taiwan, specifically in the facilities of one company, TSMC, Taiwan Semiconductor Manufacturing Company. That concentration scared governments. A single typhoon, a single military miscalculation, a single disruption to that supply chain, and the global economy stalls. Then came the CHIPS Act. Signed into law in 2022, the CHIPS and Science Act committed $52 billion in federal funding to rebuild semiconductor manufacturing on American soil, alongside a 25% tax credit for qualifying capital investment in domestic fabs. The response from the private sector was historic. The Semiconductor Industry Association reports that since 2022, companies have announced more than $540 billion in private investment across more than 100 semiconductor projects in the United States. In Arizona alone, TSMC is building what could become the most consequential manufacturing cluster in American history. Its first fab, Fab 21 Phase 1, entered high-volume production in early 2025, manufacturing 4-nanometer chips for customers, including Apple and NVIDIA. Equipment installation for the second fab, running 3-nanometer process technology, began in mid-2026, with production targeted for 2027. Plans are in place for up to 6 wafer fabs, 2 advanced packaging facilities, and an R&D center on Arizona soil. But here is the challenge nobody is talking about loudly enough. You can authorize the funding. You can break ground on the fabs. You can install the equipment. What you cannot do is manufacture an experienced semiconductor engineer overnight. The Semiconductor Industry Association projects a shortfall of approximately 67,000 semiconductor workers in the United States by 2030. Technicians, engineers, and computer scientists combined. Design engineers with experience in advanced packaging and sub-3 nanometer process nodes are among the most sought-after and hardest to find talent in any industry right now. The fabs are being built. The workforce to run them is not keeping pace. And that gap matters not just for business, it matters for national security.
The immigrant visionary. His name is Morris Chang. He was born in 1931 in Ningbo, China. He grew up amid wartime upheaval, fleeing first to Shanghai, then Hong Kong, as the Chinese Civil War reshaped his country around him. In 1949, at the age of 18, he crossed an ocean. He came to the United States with almost nothing except ambition and a belief that American institutions could shape what he might become. He enrolled at Harvard. He transferred to MIT, where he earned his bachelor's and master's degrees in mechanical engineering. His employer, Texas Instruments, later sponsored his doctorate at Stanford University, where he earned his PhD in electrical engineering in 1964. At Texas Instruments, Morris Chang rose steadily for 25 years, eventually becoming Group Vice President responsible for the company's global semiconductor business. He had identified something that almost no one else saw. Electronics companies were increasingly designing chips they did not want to manufacture. The capital cost of a fabrication facility was enormous. The expertise required was specialized. Many firms would rather outsource that step entirely. Chang left Texas Instruments, went briefly to another firm, and then, when the government of Taiwan came calling, he said yes. In 1987, Morris Chang founded TSMC. He invented a business model, not a chip designer, not an integrated device manufacturer, a pure-play foundry, a company that made chips for other companies and nothing else. Intel turned him down. Texas Instruments turned him down. He found backing from the Taiwanese government and Philips. History has a verdict on those early decisions. TSMC today is the most critical node in the global technology supply chain. Every leading-edge chip that powers an iPhone, an NVIDIA GPU, or an AI data center almost certainly passed through TSMC's hands. Morris Chang spent 36 years in the United States. He was trained in American universities. He built his expertise in American companies. He became a citizen of this country. And then he took all of that, the engineering discipline, the commercial instincts, the belief in the pure play model, and used it to build the company whose Arizona fabs are now at the center of American chip sovereignty strategy. The Immigrant became the architect of the industry. America now needs to rebuild at home. That is not irony. That is exactly how innovation works.
Feeling lost in a maze of visa types and paperwork? Don't know where to turn? We've got your back. With clear answers and real help, we'll guide you every step of the way. Let's navigate it together. Your journey starts today.
Hello, you must be Clara. Welcome to the law office of Chris M. Ingram.
Finally, I found a law firm that will help me achieve my American dream.
At this law firm, you are important to us. That's why we will be with you every step of the way. So join us at the office of Chris M. Ingram.
Need help with your visa? Book your free consultation now at www.breakthroughusa.com and let us take care of you.
The immigration strategy. Meet Elena Kaufman. She is 37 years old, a semiconductor process engineer originally from Stuttgart, Germany. She spent 8 years at Infineon Technologies, one of Europe's leading chip makers, specializing in advanced packaging, specifically heterogeneous integration and chiplet assembly, the technologies that allow multiple chips to be combined in a single package for maximum performance and power efficiency. These are not commodity skills. Advanced packaging engineers with experience in heterogeneous integration are among the most sought-after professionals in the semiconductor industry right now. The reason is structural. As chip miniaturization approaches physical limits, the gains increasingly come from how you package and connect multiple dies together rather than simply shrinking the transistor. Elena knew what her skills were worth. When TSMC's Arizona expansion began to draw talent from around the world, she received an approach she could not ignore, a lead process engineering role on the advanced packaging team, the kind of work shaping what American chip manufacturing would look like for the next decade. She accepted. She moved to Phoenix. She arrived on an H-1B visa. The work was everything she had imagined. The scale, the access to cutting-edge tooling, the collaboration with engineers from Japan, South Korea, India, and Taiwan. The real, tangible sense that what she was doing mattered, not just commercially, but strategically. But the H-1B comes with a calendar. Elena's employer had not initiated a green card process. They had not said they would not, but they had not said they would either. And the weighted H-1B lottery had tightened the timeline in ways nobody had fully communicated to her when she accepted the role. Germany is not a high-demand country in the employment-based green card queue. She did not face the multi-decade backlog that Indian nationals in EB2 or EB3 categories do. Her challenge was different. Her employer had not moved. The petition was hers to drive, if she knew she could. She did not know, until she searched, until she found BreakthroughUSA.com, until she read what the EB2 National Interest Waiver actually meant for someone in her position. She called the law offices of Chris M. Ingram. As attorney Chris M. Ingram explains, Elena's case is a strong example of a profile that is genuinely well-positioned for EB2NIW. Advanced packaging expertise tied directly to CHIPS Act implementation, publications in the field, and an employer whose work is explicitly connected to domestic supply chain security. This is exactly the kind of case where the national importance argument is not abstract. It is specific, documented, and current. What is EB2NIW, and why does it matter for semiconductor engineers? The EB2 National Interest Waiver allows qualified professionals to self-petition for a U.S. green card. No employer sponsor, no perm labor certification, no waiting for a company to decide whether your immigration future is worth their legal budget this quarter. To qualify, an applicant must meet one of two standards. Either they hold an advanced degree and are working in their professional field, or they possess exceptional ability, significantly higher expertise than ordinarily found in that field. Beyond that baseline, they must satisfy the three-part Dhanasar test. First, the proposed endeavor has substantial merit and national importance. For a semiconductor engineer working in advanced packaging at a CHIPS Act-funded facility, this prong has never been easier to establish. The U.S. government has committed $52 billion and leveraged $540 billion in private investment, specifically because it has determined that domestic semiconductor capability is a matter of national importance. The U.S. CIS adjudicator, reading an EB2NIW petition for an advanced packaging engineer in Arizona, is reading that argument in a context where the federal government has already answered the question. Second, the applicant is well-positioned to advance the proposed endeavor. Here is where the specifics of an engineer's record do the work. Technical publications, patents, process innovations, citations in the field, peer reviewer roles, expert witness or advisory contributions, and letters from recognized authorities in semiconductor manufacturing. The record does not need to be extraordinary in the EB1A sense. It needs to be substantive and specific. Third, on balance, it would be beneficial to the United States to waive the job offer and labor certification requirements. For an engineer filling a role that the SIA projects tens of thousands of positions cannot be filled from the domestic pipeline alone. This prong practically argues itself. Attorney Chris M. Ingram puts it plainly. The NIW was designed for exactly this kind of case. The country has explicitly said it cannot build its chip manufacturing sector fast enough with the domestic talent available. An engineer with advanced packaging experience working at a CHIPS Act facility is contributing to something the government has already designated a national priority. The connection between their work and the national interest argument is direct and documentable. What happened with Elena's petition? Elena's petition was assembled around three pillars. Her technical publications on heterogeneous integration protocols include 2 peer-reviewed papers and 1 conference presentation at SEMI's annual Advanced Packaging Forum. Letters from 2 distinguished researchers in the field, one from a professor at Arizona State University's Semiconductor Research Program, and one from a senior engineer at a national laboratory, who had independently cited her published protocols in their own work, and a policy framing document prepared with guidance from the law offices of Chris M. Ingram that connects her specific contributions to the CHIPS Act's stated goals regarding domestic advanced packaging capability. The petition moved cleanly. No RFE. US CIS approved the I-140. The priority date was current for her country of birth. Elena's green card followed within months. Her husband, who had been on a dependent H-4 visa and not authorized to work, applied for a work authorization shortly after. He now works in supply chain logistics, a field that, it turns out, is also experiencing significant chips-related growth in Arizona. A listener shared this on Google, and it reflects how Elena felt at the end of this process. I am writing this review to express our heartfelt gratitude to the Chris M. Ingram Law Group for their exceptional support and dedication throughout the case. The approval of his case, just 1 day before Christmas Eve, felt like the most wonderful holiday gift we could have hoped for. A special thanks goes to Lazaro, the caseworker assigned for petition. Lazaro's exceptional expertise, patience, and unwavering commitment are highly appreciable. he was always available to address any questions or concerns throughout this process. The entire team at Chris M. Ingram Law Group demonstrated professionalism, attention to detail, and a genuine passion for their work. Their collaborative approach and in-depth knowledge of immigration law truly set them apart. We are immensely thankful to Lazaro and the entire team for their incredible efforts, and we highly recommend the Chris M. Ingram Law Group to anyone seeking expert legal services. The action plan. Step 1. Understand that your field is explicitly on the national interest map. The CHIPS Act is not background context. It is a legal and policy infrastructure that directly supports the national importance argument in an EB2 NIW petition. An engineer working in advanced packaging, process development, yield improvement, or supply chain integration at a CHIPS-funded facility is already working in a designated national priority area. Step 2. Build your record deliberately. Publications in peer-reviewed journals and recognized industry conferences, such as SEMI or the IEEE International Electron Devices Meeting, are the strongest currency. Patent applications matter. Process innovations that are documented and credited to you matter. Citations in other engineers' work matter. If you are not actively tracking these things, start now. Step 3. Identify your expert network. The letters that do the most work in an NIW petition come from researchers and practitioners who know your specific contributions and can speak to them with specificity rather than generically. Think about who in your field knows your work well enough to write that kind of letter. Step 4. Do not wait for your employer. This is the most important step. The national interest waiver belongs to you, not to your company, not to your HR department, not to a perm process that may or may not happen, depending on your employer's budget priorities this fiscal year. Your contribution to American chip sovereignty is yours. Your petition can be yours too. Attorney Chris M. Ingram notes, "We speak to semiconductor engineers regularly who assume their employer is handling their immigration, or who did not know self-sponsorship existed. In a field where the government has already documented a talent shortage of tens of thousands of positions, the case for national importance is not a stretch. It is the obvious conclusion. The work is to present it correctly." Elena today. The approval came on a Thursday morning. Elena was reviewing yield data from an overnight run when the notification came through on her phone. She read it twice, then she forwarded it to her husband, and she went back to the yield data. Her green card arrived 8 weeks later. She has since been promoted to lead a cross-functional packaging integration team, with engineers from 4 countries working on the CoWoS advanced packaging protocols that will define how AI chips are assembled in the United States for years to come. She is not waiting on a lottery anymore. She is not dependent on her employer's HR calendar. She is permanent. She is building. Morris Chang arrived in the United States as a teenager with nothing except the ambition to study and build. He spent 3.5 decades here, trained at MIT and Stanford, forged at Texas Instruments, naturalized as a citizen. He took that formation and used it to invent a business model that now underpins the entire global technology economy. The engineers sitting in TSMC's Arizona fabs right now, and in Intel's Ohio complex, Samsung's Texas facility, and dozens of CHIPS-funded facilities from New York to New Mexico, are building what comes next. Some of them are on H-1B visas. Some of them do not know they could self-petition today. If that is you, the question is not whether your work qualifies as nationally important. The federal government answered that question by committing $52 billion to your field. The question is whether you know how to turn that into a green card. Visit breakthroughusa.com and start that conversation. The law offices of Chris M. Ingram has spent more than 2 decades building immigration cases for the people doing the most critical technical work in the United States. Chip sovereignty starts with keeping the engineers who are building it. As attorney Chris M. Ingram says, "The CHIPS Act built the case for you. Let us help you file it."